Resultant moments. Example 3, we have a uniform light rod. So this rod here in black, its mass and hence weight can be ignored. Now we can take moments at any point we like on this rod, but we're going to choose this point, point P. We're given the forces, but the distances to these forces are not the perpendicular distances. There isn't a right angle here, there is not a right angle here. So we have to work out the perpendicular distance between point P and each force. So I'm looking for the shortest distance between point P and this force, and it will be about here, where you will have a right angled triangle here with the right angle right there. And likewise I'm looking for the shortest distance between point P and this force arrow here. So again you can see that distance is getting shorter and shorter until you get a right angled triangle. So there's a right angle right there. Now this is the perpendicular distance between point P and the force. So in this blue triangle, this is the hypotenuse. We have the angle and we're looking for the opposite side. So we need to use the sine function. In this red triangle, we have the hypotenuse, which is 4 meters, and we're looking for the side opposite the angle. So hypotenuse, opposite, we need to use the sine function. So 3 sine 40, 4 sine 80, perpendicular distance here. We can now calculate moments. So we start by stating which direction will be positive. I've taken clockwise as positive, and no big reason why I've chosen clockwise. Force times perpendicular distance to calculate moments. So relative to this point here, point P, this force, the 5 Newton force, will create a rotation in this direction, which is going clockwise about P. Clockwise is positive, so this one's positive. And the 4 Newton force about point P, it's trying to rotate things in this direction. So around P, this will be anti-clockwise. So that's negative. Simplifying, we have a positive answer at the end, which means the final resultant moment will be in this direction, the direction we originally stated, so clockwise. Example 4. Now this is identical to example 3, so most of the working out will be the same as example 3, but the addition here is this 6 Newton force acting vertically down on our light rod. So taking moments about the point P and taking the clockwise direction as positive, the moments due to the 5 Newton force and 4 Newton force we've done already. That was in example 3. I'm not going to explain those again. This one here, the 6 Newton force, the perpendicular distance from our point P is 3 meters, and the 6 Newton force will produce an anti-clockwise moment, so it will be negative like this. So positive, negative, negative. Simplify. Minus 6.02 Newton meters. It's a negative answer, which means our resultant moment has a direction which is opposing what we stated originally. That's clockwise, so it will be 6.02 Newton meters anti-clockwise. For practice, try these questions.